Today we're going to take a look at lesson 4 or 5, which is about solving rational equations. The difference between this lesson and past lessons are now we can actually take a problem and get an answer. So for example, here's a couple problems. Well, actually, I think they're the same problem. Um, but you can actually do some math to get an answer where your variable equals something. In the past, we were dealing with expressions. There was no equation. So all you could do essentially is just simplify it, just kind of make it a little bit neater, right? That's about it. So let's go ahead and take a look at the bottom down here. Solve a rational equation. A couple of things just before we jump into it and solve A and B. They're just saying that a rational equation is basically an equation with a fraction in it, right? An equation that contains a rational expression. And then this little study tip, make sure you're reading these things. A fraction with a denominator equal to 0 is undefined. If you think back to the last couple of lessons, we'd simplify that expression, and then we'd have to create domain restrictions, basically saying what x couldn't equal because you cannot divide by 0. And like this is saying, that creates something that's undefined. In this case, you're actually going to start with the problem, do the work, get an answer, and then all you have to do is check that one answer. So you're not really having to come up with a domain restriction. -7/2 is the only thing that satisfies this equation. So as long as when you plug in -7/2, it doesn't give you a denominator of 0, you're good to go. You don't have to list domain restrictions. So we'll start off with A, which is 1 over x plus 4 equals 2. This problem is, there's always, I've said it a million times, right? There's tons of different ways to do these things. There's different first steps, there's different ways in general. Like, I think that's really what they're emphasizing up here with these two people. It looks like they're kind of doing a couple of different things, but notice that they both get down to the correct solution. And the important thing is everything that they're doing is mathematically sound. Like it's quote unquote legal in math land, right? So everything they're doing is fine. They get the correct answer. Nikki takes one route, Tavon takes another. It doesn't matter how you get there as long as everything you're doing is mathematically sound and you get the correct answer. Just keep that in mind. The analogy I always tell people every year is like if you wanted to drive from Timberline to the west side, there's different ways you can go. You can jump on the freeway, right? You can go through downtown. There's different ways you can get there, and we'd all still end up on the west side. But it's not what takes you there. It's that you get you meet, right? Or the end result is the same. That's what I'm trying to say. So for A, I think I'm going to show you a couple different ways for A and B. So with this one, I'm just going to rewrite it just to emphasize something here. That 2 is the same thing as 2 over 1. I can take any whole number, even if it was just x, I can rewrite that as x over 1, just to kind of emphasize that these are two different fractions. What I want to do, and again, I'm using this knowledge that I've learned in the last couple of lessons to help me out with solving these equations. I know that I can't just solve this the way it sits. Typically, when we're at the point we're at now, typically the first step is to always get rid of your fractions. That is like when I look at a problem, it can be a basic problem like this. It could be super advanced. My first goal is to get rid of the fractions, okay? And the way we're going to do that is multiply both sides by that denominator. Well, this denominator is just 1, so I don't care about that. This denominator is x plus 4. That's what I care about. So what I'm going to have to do is multiply both the left and the right by x plus 4. Because this is essentially what's happening. When I do that, this is technically x plus 4 over 1. Same thing with this. This is x plus 4 over 1. And what I can do is this is x plus 4 in the top. This is an x plus 4 down below. I can simplify that out, right? That simplifies out. Now you might be thinking, wait a second, in the past, we talked about, in the past couple of lessons, we had to multiply by x plus 4 over x plus 4. You're right. In the past, we had to because those were expressions, not equations. So if you're dealing with an expression, you'd have to multiply both the top and the bottom by x plus 4 if there is not an equal sign here. If this was 1 over x plus 4 plus 2, then that's what you'd have to do. You'd have to multiply this second fraction by x plus 4 over x plus 4 and go about it that way. Because this is an equation now we can balance these things out. You can do something to the left side as long as you do the same exact thing to the right side. It balances it out. So on the left, x plus 4 over x plus 4, I can simplify that out. That just gives me 1. And on the right, I've got 2 over 1 times x plus 4, and I'll just kind of clean that up a little bit. It's just 2 times x plus 4. Now's the point where I can keep solving this problem. Keep in mind, when we first started off, we had a fraction. That's what I want to get rid of. I want to turn that fraction into just a single level thing. That's what I have now. I don't have any more fractions. So this is basically algebra 1 stuff. I can distribute that 2. I get 1 equals 2x plus 8. I'll subtract 8 from both sides, so I get negative 7 equals 2x, and then divide both sides by 2, so I get x equals negative 7/2. So that's one way we can do this. You can multiply both sides of the equation by whatever that denominator is. You might need just one thing. You could need a couple things. It just depends on the problem, what you're going to use. I think on the right half, I'm going to go ahead and use b. And b is 1 over x minus 3 equals 5. And now I'm going to approach this a little bit differently. It's up to you, whichever method you want to use, if one makes more sense than the other. Sometimes certain methods might take a little less ink and a little less space on your paper, but they don't make sense. Other methods might take a little more ink and a little more space, but it does make sense. So it's completely up to you, whichever method you want to use. I'm going to start off the same way, just emphasizing that this is technically 2 different fractions. 1 over x minus 3 equals 5 over 1. And what I'm going to do here is I don't know if it's technically called this, but it's almost like a shortcut, this method here. I'm going to do what they call cross multiply. So I'm going to multiply the 1 times the 1. So that gives me 1. And then I'll multiply the other way, the 5 times the x minus 3. By doing this cross multiplication, it gets rid of your denominators and it leaves you with just a single level equation. Does it matter what goes where? Absolutely not. I could have done 5 times x minus 3 first, and then on the right side done 1 times 1. It totally doesn't matter where you place these things. So you could have had it like this, or you could have flip-flopped it and had 5 times x minus 3 equals 1. And then now I'm just kind of back to, like I said earlier, that those algebra 1 steps where I distribute that 5. And then I'm going to go ahead and add 15 to both sides. So it's 16 equals 5x. Divide both sides by 5. So I get x equals 16/5. Again, 2 different methods. Really, if you break it down and look at it, this is essentially this method here where you're multiplying both sides by that denominator. It's just a shortcut way of thinking about it, okay? Just cross multiplying like that. Keep in mind, this only works when you have a single fraction equal to a single fraction. So you could not do something like this. 1 over x plus 7 equals, I don't know, x over 3, something like that, right? If I have a binomial, if I have 2 terms on one side of the equation, you can't do that. You would have to only have something like 1 over x equals x over 3 or something like that, right? You can't have 2 or more things. It just has to be a single term on each side of the equation. All right, all right. So we're on page 225, example 2. Solve a work rate problem. Arthur and Cheyenne can paint a wall in 6 hours when working together. Cheyenne works twice as fast as Arthur. How long would it take Cheyenne to paint the wall if she were working alone? So just kind of a little visual representation of what they're talking about here. Make sure you're understanding, and when you read that section or that introduction, the information they're giving you. So it's really important that they're telling you that Arthur and Cheyenne can paint the wall in 6 hours. So if I take Arthur's time and I add it to Cheyenne's time, they're going to paint that wall in 6 hours. Okay. When working together, Cheyenne works twice as fast as Arthur. So Cheyenne is going to work twice as fast as Arthur's pace. So if we find out that Arthur can paint this wall in 2 hours, right? Cheyenne works twice as fast. So she's going to paint the wall in 1 hour because she works twice as fast, right? How long would it take just Cheyenne to paint the wall if she were working alone? So that's what we're trying to figure out. Step 1, what you have to do is determine what they're calling the work rates for both Arthur and Cheyenne. So they're saying let X represent the number of hours Arthur needs to paint. And the reason why is because if you did X for Cheyenne, you'd be dealing with fractions. Because if we said that Cheyenne works twice as fast, then I can just multiply Arthur's time by 2. But if I go the other way around and I say that Cheyenne works twice as fast and I use Cheyenne as the variable, then it's going to have to deal with 1/2, right? The least, or we're going to use the minimum amount of fractions that we can use. So we'll stick with 2 times something instead of 1/2 times something. So let X represent, so the variable is going to represent the hours that Arthur needs to paint the wall. Arthur can paint the one wall in X hours because we don't know how much time it's going to take. So they can do one job, one wall in X hours. So the way we represent that is with a fraction. One wall, one job over X hours. So one job takes X hours, okay? Similarly, Cheyenne, if she works twice as fast, instead of doing one wall in that same amount of time as Arthur, she's going to do 2 walls in the same amount of time as Arthur, right? So just to clarify that, this fraction represents that Arthur can do 1 wall in X amount of time. So our variable is representing Arthur's time. So when we start to set this up for Cheyenne, now we have to say Cheyenne can do 2 walls or 2 jobs in the same amount of time, in X amount of time. Because remember, this X represents Arthur's time, not Cheyenne's. So we have to say Cheyenne is working twice as hard. And then together, they already gave us that. Together, they can do 1 job in 6 hours. So that's how we're setting it up. So I've got Arthur's piece. And if I add that to Cheyenne's piece, it's going to give me the total amount. Okay. In this case, it looks like both of these fractions have a common denominator. So I should be able to just add them together. And now I'm kind of back to where I was at with that first problem, right? I've got a single fraction equal to a single fraction. So instead of multiplying both sides by that denominator like I did with part A, I like B. B for me makes more sense. It's a lot simpler. I've got 1 fraction on each side. I can just cross multiply. So that's exactly what I'm going to do. So I'll cross multiply. It doesn't matter which one goes first. So I'll do this one first, just because I did the other one first last time. So X times 1 is X. 3 times 6 is 18. Nothing to simplify, nothing to, distribute or, solve for. It's already solved. It's X equals 18. So remember what X represents. X represents Arthur's time, right? X represents Arthur's time. Let's make sure we got the same answer, right? If Cheyenne works twice as fast, Okay, she works twice as fast. If Arthur can paint the one wall in 18, what is it? Minutes? Hours. 18 hours. Then Cheyenne is going to paint the wall in 9 hours because she works twice as fast. She covers twice as much area. She could paint twice as much area as Arthur. All right. Example 3. All right, so identify an extraneous solution. Whoops, let me get on the screen. We've dealt with this before. You can look down here. The solution x equals 5 is an extraneous solution because it makes the value of the denominator in the original equation equal to 0. So an extraneous solution is basically the same thing as a domain restriction. It's something that's going to make your denominator equal 0, which we learned off the last page, right? Over here makes it undefined. So we'll have to look out for that. So what is the solution of this equation? So this is definitely a bigger equation, but just keep in mind, it's the same steps that you've been learning. You can't add two fractions unless they have a common denominator. And then once I have a common denominator, I can add them and then I can multiply the diagonals, right? Again, a few different ways to approach this problem. It's completely up to you. If I show you a method with this example and you're like, is there a different way you can do this? Is that, is there something else I can do, or can I do this way? Just make sure you email me and contact me and we'll go through the steps and make sure everything's good to go. But I think the way that I would do this is to come up with a common denominator for everything. I think my first step is gonna be factor that quadratic. So for example 3, I'm just gonna factor this really quick. X squared minus 8x plus 15. So that's gonna be -5 and -3. So it's actually these denominators right here, okay? So I'm gonna go ahead and write down what we have. It's going to be 1 over x minus 5 plus x over x minus 3 equals 2 over, and we said it's x minus 5 times x minus 3. I like to put everything that's a binomial or higher in parentheses, just for me, just visually to do that. You don't have to. All right, so remember, a least common denominator, a common denominator that I'm looking for. This fraction has an x minus 5. So I know my LCD has to have an x minus 5 because if in order for me to work with this, it has to have the same denominator. This denominator is an x minus 3. So I know my LCD is also going to have an x minus 3. Look at your third fraction. It already has the denominator that I need. So I'm not going to have to do anything over here. So what I'm going to do here is I'm going to multiply both sides of my equation by this LCD. Again, other steps, there's other ways you can do this. I just think this is the most straightforward. So what I'm going to do, and I think I'm going to go ahead and erase that just so I can write on top of that, is I'm going to multiply the left side. So I'll put it in huge brackets like that. I'm going to multiply the left side by x minus 5 times x minus 3. And I'm going to actually multiply, I'm going to also multiply the right side by, see if I can squeeze this in here, x minus 5 times x minus 3. Remember, with expressions, you have to multiply by something over itself. So I would have to multiply by x minus 5 times x minus 3 over x minus 5 times x minus 3. Since this is an equation, I've got two sides of my equation. I can just multiply both sides by the same thing. It doesn't matter what it is, as long as you're multiplying both sides by the same thing, you're good to go. So think about this like distribution. I'm going to distribute that and distribute that. So x minus 5 times x minus 3, and then I'm going to distribute it to my first term. What I'm going to have, and I'm going to go ahead and write this all out. So, this is going to be a lot on the paper, but I have x minus 5 times x minus 3 over x minus 5. And then the second fraction, I have plus x times x minus 5 times x minus 3 over x minus 3 equals 2 times x minus 5 times x minus 3 over x minus 5 times x minus 3. So essentially what I did is I multiplied all three fractions by x minus 5 times x minus 3. You can see that they're all in the numerator of all three fractions. Now what I'm going to do is go ahead and simplify each fraction. So I have an x minus 5 up top and down below. I have an x minus 3 up top and down below. And then an x minus 5 up top and down below, and an x minus 3 up top and down below. So by doing this, by coming up with the LCD and then multiplying both sides of that equation by that LCD, I'm able to look at the denominator. I'm able to eliminate all my denominators. So what's left? In my first fraction, all I have is an x minus 3. In my second fraction, I've got x times x minus 5. And then in my third fraction, I've just got a 2. So now I'm back to algebra 1 stuff, right? Where I've gotten rid of the fractions. I have no more denominators. Now I can just focus on things like PEMDAS and distribution and solving for x. So let's go ahead and move forward. I'm going to go ahead and distribute that x. So I'll have x minus 3 plus x squared minus 5x equals 2. I'll combine my like terms. And since I'm seeing an x squared here, I'm going to go ahead and set this equal to 0. So I'm going to go ahead and subtract 2 from both sides. And at the same time, I'm just going to put everything in standard form. So I'll put my x squared first. Then I have a negative 5x plus x, so that's negative 4x. And then I have a negative 3 minus 2, so that's negative 5. And that equals 0. And now since I have a quadratic, I know that that's telling me to factor. So what you can do is you can do the cross method if you need to, or you can just factor it in your head. A times C is negative 5. B is negative 4. Two numbers that multiply to negative 5 and add to negative 4 are negative 5 and 1. So what I have here is x minus 5 times x plus 1 equals 0. So if I solve this, remember this is the portion where you're setting each one of these equal to 0 and solving, because that's what I want to figure out. I want to figure out when these are going to be 0. So here I'd add 5 to both sides, so I get x equals 5. Here I'd subtract 1 from both sides, so I get x equals negative 1. You can go that route, or remember, you can always just take the opposite of those two numbers. Once you've figured out what those two numbers are, just take the opposites, positive 5, negative 1. So with this problem, do both positive 5 and negative 1 work? This is an important last step to verify that both of these answers are solutions. If I plug in 5 to everywhere in my denominator, am I ever going to have 0? Yeah, right here. 5 minus 5 is 0. I can't have a denominator where it's 0. So I have to exclude 5. That's not going to be an acceptable answer. What about negative 1? Negative 1, that won't be 0. That won't be 0. Nope, nope. So negative 1 is good. So I think this problem was looking for the extraneous solution. Yes, it was. So in this case, after we did all the math, solved, got my two answers, got my two possible answers, I need to verify that both or one of these answers won't make my denominator 0. In 5's case, it did. So I have to exclude that. So technically, that is not an answer. All right. Let's see what else they're saying down here. Looks like they're going into some more stuff down below. Extraneous solution. Oh, and you can confirm it with graphs if you wanted to go to Desmos and type that in. That's what they're talking about. They're also getting into this, which I'm kind of surprised to see it because I didn't anticipate this being in here. Vertical asymptotes. So horizontal lines are left to right, verticals are up and down. And you can see what they call these asymptotes. These are those dotted lines that are right there. And the reason why those asymptotes are there, which is more of a pre-calc thing, I don't think we're actually going to get into asymptotes, is because that's the point where you cannot, the function does not exist. So take a look at 5 right here, right? There's that vertical asymptote at x equals 5. And notice that this function doesn't ever touch it, right? It'll continue to get super, super, super close to it. It'll be, you know, infinitely close to it, but it'll never actually reach 5. So that's what it's creating. These extraneous solutions are creating asymptotes where your function doesn't exist. Example 4, solve problems. So I think this is the same thing. Let's go ahead and do A. 5, actually, I'm gonna kind of give myself some space here. 5x over x minus 2 equals 7 plus 10 over x minus 2. All right. You know, like I said, there's a couple things you could do here. One thing you could do is very similar to what we did on the last problem and just kind of ignore the left side and then create a common denominator between these two terms, right? Once you create a common denominator, you can add them together, and then I can do that cross multiply thing. I'm not sure how the book tells us to go through it, but I think what I'm going to do, because I already see that 2 of these have a common denominator, I'm going to kind of manipulate this equation a little bit. And here's what I'm going to do. So I'm going to go ahead and subtract 7 from both sides. Oh, you know what? I changed my mind. Now that I thought about that right after I wrote that, I'm not going to subtract 7 because that just adds an extra step. I am going to subtract 10 over x minus 2 from both sides. Then we can do it in one step. So if I do that, on the right, it's just 7. That's the only thing that's left. Then on the left, I still have 5x over x minus 2, but now I have that minus 10 over x minus 2. Well, look what I got, right? Just by manipulating that equation a little bit and moving that term to the left side, now I've got common denominators. I can add these together, or in this case, subtract them, and then I can cross multiply. So 5x and 10 are not like terms, so technically I cannot combine them. So the best I can do is this. I can't do anything else other than that. I can just kind of combine them at the top of the fraction. But now what I have is a single fraction equal to a single fraction. So now I can do my cross multiplication. So I'll do that one first. So 7 times x minus 2 equals that one second, 1 times 5x minus 10. Now I can just simplify. So I'll distribute the 7 and then distribute the 1, which doesn't change anything. And now I'm going to go ahead and solve. So I think I'm going to subtract 5x from both sides and then also add 14 to both sides. So that gets rid of the 5x on the right. Negative 10 plus 14 is 4. Negative 14 plus 14 is 0. 7x minus 5x is 2x, not negative 2x, just 2x. Now to solve, I'll divide both sides by 2, and I get x equals 2. Keep in mind, though, once you get that answer, you always have to check it. We're at the point in our math career that you have to check and make sure that that answer is acceptable. If we go back up to our problem, if x equals 2 and I plug in 2, it doesn't matter what's up in the numerator. That you don't care about that, just the denominator. 2 minus 2 is 0. You cannot have 0 in the denominator, so that will not be a solution. Okay, so in this case with example 4, it just doesn't have any solutions. There's no solutions. Let's see what they end up saying. Solve for x and then check the solution. Let me just get the terminology. Yeah, they're just saying the equation has no solution. So That's what you could write. If you're doing this problem on a piece of paper, you could X that out and just write no solutions. And then there's a part B, pretty much the same thing. So I'm going to do it the exact same way because I feel like that was the cleanest way to do it. I'm going to go ahead and subtract x over x minus 3 from both sides. So then I have the original fraction on the left, 3 over x minus 3 minus x over x minus 3 equals negative x over 4. Since those have common denominators, I can combine or add the numerators. In this case, they're not like terms, so I can just, put them together. I'm going to go ahead and rearrange this just because I like my coefficient or my leading variable to be up front. So instead of 3 minus x, I'm going to write that as negative x plus 3. I see, okay, so in this problem, and again, it just depends on which problem you're given, you could go straight into diagonally multiplying, right? Perfectly acceptable, move forward, solve for x, and you'd be good to go. The other thing that I'm noticing that's very specific, and I don't know if they intended for this to be on here or not, is that if I GCF out a negative with that numerator, if I take a negative out, look what I got, right? I've got an x minus 3 up top and an x minus 3 down below, so I can simplify that. So on the left, technically what I have is negative 1. On the right, I've got negative x over 4. Again, do you have to do that? Absolutely not. You could have multiplied, diagonally and moved forward with that. You'd get the same answer. So here I will multiply diagonally. So negative 1 times 4, that's negative 4. And then 1 times negative x is negative x. I'll go ahead and divide both sides by negative 1. So I get x equals 4. Again, plug that in. Looks like I'm good to go. 4 minus 3 is not 0. So that's acceptable. I can keep that answer. Let's just double check and make sure. Interesting. Okay. So if you look at their steps that they have here, they essentially did what we did at the very beginning, where you're going to multiply everything by that common denominator. So they're saying the common denominator was 4 and x minus 3. So notice that they multiply both sides of that equation by 4 and x minus 3. So then they simplified it, cleaned it up. They ended up with a quadratic. They ended up factoring that quadratic and getting 2 different answers. But if you read the instructions down here, when you go to check them, the 3 doesn't end up working because it gives you a denominator of 0, but the 4 does. So here is a great example of, here is one way to do this problem. It doesn't mean it's right or wrong. It's just a different way to do it. It gives you 2 possible choices where only one of them works. Or here's a different way, right? Where I just change this equation. I subtract x over x minus 3 to the left side. They already have common denominators, so I can add them together. I cross multiply or simplify, right? Always different ways to do these problems, but what do you notice, right? The answer is the same. We both got x equals 4, so good example. So here is example 5. We're on page 228. Solve a rate problem, paddling with a current in a river. Jake traveled 16 miles. Even though he paddled upstream for an hour longer than the amount of time he paddled downstream, Jake could only travel 6 miles against the current. In still water, Jake paddles at a rate of 5 miles per hour. What is the speed of the current in the river? So it's kind of like a rate problem like we did before with the painting example. I think it was example 2. Uh, but now they're going to give you, it's basically setting you up with an equation like we just saw with the last example. So the place that trips people up with problems like example 5 is setting them up, right? I mean, you really want to read through this and get an idea of the information it's giving you, as well as kind of look at the picture. You know, you could see that he's going 16 miles downstream and then 6 miles upstream, and that kind of makes sense, right? So here's how you set up that problem. They're just saying that C represents the current. They're just using C because current starts with C. You could use X if you wanted to, it doesn't matter. But they're using what we talked about. Who was it, last week or the week before? I can't remember. Where it was the distance formula. Distance equals rate times time. Something we talked about in that lesson, again, it was last week or the week before, is I can take that equation and depending on what I want to solve for, I can manipulate it, right? So instead of having distance equals rate times time, if I wanted to solve for rate, I can divide both sides by t, and I get rate equals distance divided by time. I think in this case, they're looking for the time, that what's the speed of the current in the river. So they're looking for the time formula. So time equals distance divided by rate. This is kind of including, or this is kind of talking about how they're setting up this equation. And let me just point some things out. So let me get the top of that in here. They're telling you that paddling with the current in the river, right? Jake traveled 16 miles. So for the first fraction, they have 16 in the numerator because that's how many miles he traveled. But then his paddle rate in still water, I think it set it up here, right here. In still water, Jake's paddle rate, 5 miles per hour. So that's giving you basically how fast he's moving in still water. We don't really care that he's going upstream or downstream. That's just his still water rate. So 16 miles per hour, 16 miles, not 16 miles per hour, 16 miles, and that's going with the current. He goes 5 miles per hour. So they're adding the rate of the current to that, right? That's why they're adding it. They're using this fraction over here because this is the one that represents going downstream. And where did they say that up here? He paddled downstream. Jake can only travel 6 miles against the current. So 6 miles against the current. And again, he's got the same rates, the same speed, 5 miles per hour in still water, but now we're subtracting the rate of the current from it. What about this one right here? Jake paddles 1 hour longer upstream than downstream. Where did they get that? Right up here, even though he paddled upstream for an hour longer. So you have to include that in your problem because they're technically not equal to each other. If he paddled upstream for an hour longer, you'd have to state that, okay? So now they're coming up with this equation. Now we can just solve this equation. I'm gonna go ahead and do this. You know, well, since I just did 2 problems where the denominator was the same, actually, these are different. So I can't do it that way. I just realized this was plus and this was minus. So what I'm going to do is I'm going to multiply both sides by that common denominator. So let me go ahead and write this out. 16. Give myself some more room. 16 over 5 plus c plus 1. 5 minus c. So my common denominator with this one has a 5 plus c. This one has a 5 minus c. Even though they're close, they're not the same. So what I'm going to have to do is include both of those in my common denominator. I'll have to have a 5 plus c and a 5 minus c. So what I'm going to do is I'm going to multiply the left side of that equation and the right side by 5 plus c and 5 minus c. 5 plus c, 5 minus c, 5 plus c, 5 minus c. Okay. I think instead of showing you every step like I did before, like I did with this previous problem, where I showed that I multiplied it by every fraction. I think we can just do this without having to do that. So if I multiply 5 plus c times 5 minus c to the first fraction, the 5 plus c's are going to be what's eliminating, right? Those are going to be the two that eliminate. So the only thing I'll have left in my numerator is the 16 times 5 minus c. With the second term, I'm not eliminating anything, so I need them both to be in the second term. And then on the right half, when I multiply these two things together, I've got a 5 minus c down below, a 5 minus c up above. So those will eliminate. The only thing I'll have left is the 6 and the 5 plus c. So now I have a bunch of stuff, but again, it's kind of algebra 1 level stuff. I just got to distribute. I've got to FOIL things out, combine like terms, all that kind of stuff. So let's go ahead and do that. I'll distribute the 16. So that's going to be 80 minus 16c. These two binomials, I'll multiply those together. So all I'm doing is FOILing. First times first. Outside times outside. Inside times inside. And then last times last. And then on the right, again, I'll distribute 6. I don't know why I just wrote 6. 6 times 5 is 30 plus 6c. All I really did there is distribute and multiply things out. Now I'm going to combine like terms. I see I have a c squared over here, so I'm going to go ahead and write that first. I've got a negative 5c plus 5c, so I can eliminate those. I've got a negative 16c. And then 80 plus 25 is 105. And on the right, I've got 30 plus 6c. So here's the point where I can go ahead, since I have a quadratic, I can go ahead and set this equal to 0. So I'm going to subtract 30 and subtract 6c from both sides. So I have negative c squared minus 22c plus 75 equals 0. I cannot factor this unless that leading coefficient is positive. So I know I'm going to have to GCF out a negative from this quadratic. So that's going to turn this to a positive c squared, a positive 22c, and a negative 75. So here's where I can factor it, right? Negative 75 at the top, 22 at the bottom. Two numbers that multiply to negative 75 but add to 22, I think are going to be 25 and negative 3. And then since my a value is 1, I don't have to divide by 1. So my answer is going to be negative c plus 25, c minus 3. So my final answer will be c equals negative 25 and c equals positive 3. Let's just make sure that that's good to go. Though neither one of those are going to create, a bad situation for us. Negative 25 and 3. If I plug in negative 25, I'm good. If I plug in 3, I'm good. So both of those answers are acceptable. I can keep them both. This was a story problem though. So let's go back and look what they were trying to find. In still water, what is the speed of the current in the river? So if these are my two possible answers, well, my speed can't be negative 25, right? It can only be 3. Speeds are like distances where they're positives, right? So I think in this case, we are going to get rid of negative 25 and only keep 3. They always say that something like this is an extraneous solution, right? You don't have to note that, you just have to not include it. So something like this where you X it out, that would show me that you're not including it. So. All right, and then on the page 229, Top of page 229, there's a little bit of a summary. So feel free to read through that. And then we will move over to the practice problems. So right now we're on page 230. Solve these equations. So for 15, we got 1 over x minus 3 equals 10. Remember, this is a lot like, I think it was example 1, where I have one term on each side. So what I'm going to do is think of 10 as 10 over 1. I'll cross multiply and solve it. So 1 times 1 is 1. 10 times x minus 3. And now I can simplify this. I'll distribute the 10. And then I'll solve for x. So I'll add 30 to both sides. Divide both sides by 10. And I get x equals 31 tenths. Again, make sure if you plug that in, it's not going to give you 0 in the denominator. I just don't like that fraction. Give me just a second just to verify that I wrote everything down. 1 over x minus 3, 10, 1, 10 times 10x, negative 30 plus, yeah, so it should be 31 tenths. 16. 15 over x plus 3 equals 3. Same idea. Just think about that as 3 over 1. I'll multiply diagonally. 15 times 1 is 15. 3 times x plus 3. Now the only thing I have to do is distribute that 3 and then solve. So I'll have 15 equals 3x plus 9. Subtract 9 from both sides. 6 equals 3x. Divide both sides by 3. I get x equals 2. And again, make sure if you plug it in, it's not going to give you an extraneous solution. 2 plus 3 is 5. That's good to go. Just can't be 0. We don't care what it is. Just can't be 0. 17. 12 over x minus 4 equals 9. Again, same idea. So I'll multiply that diagonal first. 9 times x minus 4 equals 12 times 1 is 12. If I distribute the 9, I get 9x minus 36 equals 12. Add 36 to both sides. 9x equals 48. Divide both sides by 9. X equals, can I simplify that? 3 and 16. So 48 divided by 3 is 16. 9 divided by 3 is 3. So x equals 16 thirds. And if I plug that in, I'm good to go. 5 over 3 minus x equals 1. So I'll just cross multiply. So 5 times 1 is 5. 3 minus x times 1 is 3 minus x. Now I'll just solve. I think I'll go ahead and just subtract 3 from both sides. So I get 2 equals negative x. Divide both sides by negative 1. So I get x equals negative 2. And then again, double check, make sure it's good to go, which it is. So 15 through 18, done. 19. Solve the problem. Paige can complete a landscaping. So this was, I think, example 2 or 3, where they were talking about painting. Paige can complete a landscaping job in 6 hours. Malia can complete the same job in 4 hours. Working together, how long would it take? So you might think it doesn't sound the same because before they gave us the amount. Let's go back and double check. If you looked at the one from the example, they gave us the amount it takes them to work together, that it was 6 hours, right? Well, it's still the same idea. It's still the same concept. You're just given different pieces of information. So instead of finding out what their individual work rate time was and being given how long it would take if they worked together, now it's the opposite. So they're saying Paige can complete a landscaping job in 6 hours. Malia can complete the same job in 4 hours. So There's Paige. There's Malia, right? One job in 6 hours plus one job in 4 hours is going to tell me how much time it's going to take them if they're working together. So I need a common denominator. In this case, I think the smallest number that will go into both of those is going to be a 12, right? 6 can go into 12 twice, 4 can go into 12 3 times, and then we also have this x. So I think my common denominator here is going to be 12x. The smallest number that both 6 and 4 can fit into is 12, and since there's an x over here, we have to have an x there. So what I'm essentially doing, and I'll write it like this. I don't know if this is technically, if you can do that, right? Put it across the entire equation, but I think you'll get what I'm trying to say. I'm going to multiply everything in the equation by 12x. So the first fraction will be 12x over 6. The second fraction will be 12x over 4. The third fraction will be 12x over x. And the reason I chose to multiply everything by that common denominator is this. 12 divided by 6 is just 2. 12 divided by 4 is just 3. And then x divided by x, those simplify out. So what I have now is I have 2x plus 3x equals 12. Combine like terms, solve for x. So I get x equals 12 fifths. So if they're talking about time here, 12 fifths, so what is that? That's 2 and 2 fifths. So 2 hours, 2 fifths of the hour would be 24 minutes. So it would take 2 hours and 24 minutes with them both working together to finish this job. 20. I got the hiccup, sorry. Russell and Aaron can build a shed in 8 hours when working together. Aaron works 3 times as fast as Russell. So I think this is similar to the example that we did. How long would it take Russell to build the shed if he were to work alone? So again, it is, now that I finished reading it, it's not exactly like the example from the text. It's not exactly like the example from number 19, but it's similar. You're going to set it up in a similar way. So for number 20, Russell and Aaron can build a shed in 8 hours when working together. So I'll have Russell's fraction plus Aaron's fraction equals, now I already forgot, 8 hours, 1 over 8, right? So that tells you this is Russell's, this is Aaron's, but when they're working together, when you add those two fractions, they can do one job, one shed in 8 hours, okay? Aaron works 3 times as fast as Russell. And then how long would it take Russell to build? So if Aaron works 3 times as fast as Russell, it is going to be a lot like that first example where I have Russell and Aaron. I don't know if I even spelled that right. Yep. So Russell's example would be one shed in X amount of time. I don't know, right? They didn't say it. But if Aaron works 3 times as fast, he can build 3 sheds in the same amount of time that it takes Russell to build a shed. So my numerator will be 3. And now I have an equation. Now I think I'm going to go ahead and just add these two since they have common denominators. So that'll be 4 over x equals 1/8. I'll cross multiply, so I get x equals 32. So for number 20, how long would it take Russell to build the shed if he were to work alone? It would take Russell 32 hours to build that shed alone. And that makes sense because Aaron works 3 times as fast. X represents the amount of time it takes Russell to go. So Aaron is 3 times as fast. So it's kind of expected that, you know, Russell would take a long time. So 21, solve these equations. So I think with 21, I'll go ahead and kind of do what I did before. If you would like to multiply both sides by that common denominator and go that route, you're more than welcome to. I think what I'm going to go ahead and do is just subtract x over x minus 3 from both sides. And then so on the left, all I have is -4. And on the right, I've got 3 over x minus 3 minus x over x minus 3. They have common denominators, so I can go ahead and subtract these two. So I have -4 equals 3 minus x over x minus 3. I feel like this is exactly the same as the one we did before. I can rewrite this as -x plus 3, right? That's the same thing. I just like everything to be in standard form. And I think if I go ahead and GCF out that negative, I'll have x minus 3, just like I have down below in the denominator. So I'll be able to simplify that. And I have -4 equals -1. Interesting. Since we didn't see this in the examples, I'm going to just verify that this was correct. So x over x minus 3 minus 4 over x minus 3. And now I'm just checking my work. Yeah, so everything looks good. This is a type of problem where your variable drops out. We no longer have an x, so I don't have x equals anything. I just have a statement that's not true, right? -4 is not equal to -1. They're not the same thing. So this is an example where there are no solutions. Good problem. 22. Pretty much the same thing. Actually, I'm going to do this. I'm going to do this the other way where I multiply both sides by that common denominator, just to make sure that I'm showing different ways that you can do this. So I have x squared over x minus 10 equals 100 over x minus 10 minus 10. Okay. My common denominator here is just going to be an x minus 10. This denominator has x minus 10. This denominator has x minus 10. This doesn't even have a denominator. So my least common denominator is going to be x minus 10. So essentially what I'm going to do is I'm going to multiply everything, both sides, by x minus 10. So when I do that, when I multiply the left side by x minus 10, I'll have an x minus 10 up top, which will eliminate the denominator. So all I'll be left with is an x squared. When I distribute it a second time, I'll have an x minus 10 up top. I have an x minus 10 down below, so those will cancel out. I'll be left with just 100. And then on my last term, I'll have -10 times x minus 10. So now I will distribute the -10. And since this is a quadratic, I'm going to move all this stuff to the left side. So I think what I'm going to do, 100 plus 100 is 200. So I'm going to subtract 200 from both sides. That's a -10x. So I'll add 10x to both sides, which will leave me with x squared plus 10x minus 200 equals 0. What is that going to be? 50 and 40? 50 and -40. So if I went ahead and factored this, I'd have -200 up top, 10 down below. 50 and -40 would be my two numbers. So I want to take this shortcut. Remember, you could come over here and write x plus 50, x minus 40, and then solve it, or you could just take the opposite of those two numbers. So I know that my answer is going to be x equals -50, and then x equals +40. If you want to come over here and write those factors out, solve them, you're more than welcome to. But just remember, once you come up with those two numbers, you could just take the opposites to get your answers. With this problem, I think if I plug in negative 50 and positive 40, I'm good to go. It doesn't give me a denominator of 0. So both of those are acceptable answers. Uh, 23, solve this equation. 23 is 4 over 3x plus 1 equals 12 over x squared minus 1. For some reason, I moved to really small handwriting. Okay. In this case, both of these denominators are different, right? Neither one of them are the same. So one thing you could do is come up with a common denominator, right? I think what I'm going to do is go ahead and do the cross multiplication method. If you want to multiply both sides by 3 times x plus 1 times x squared minus 1, you could. The cross multiplication method is the same thing. So what I'm going to do is cross multiply. So it'll be that one. 4 times x squared minus 1 equals those two. 12 times, I don't want to get super confusing. I think what I'm going to do is distribute that 3 here. 3 times x, 3 times 1. So that's 3x plus 3. I didn't want to do a set of parentheses inside a set of parentheses. Here's the point where you're going to distribute, combine like terms, and basically solve. I see an x squared, so I know I'm going to have a quadratic that I'm going to have to factor. So I'll distribute the 4. So that's 4x squared minus 4. I'll distribute the 12. So that's 36x plus 36. Like I said, I've got a quadratic, so I'm going to go ahead and move everything on the right over to the left. So I'm going to subtract 36x. I'm going to subtract 36. So on the right, all I have is 0. On the left, I'll have 4x squared minus 36x minus 40. I've got a GCF. You always want to take out that GCF before you try to factor something. So that's x squared minus 9x minus 10. And then if I factor this, if you want to, you can draw yourself a little x over there. I'll have 4 times x minus 10 times x plus 1. So my answers would be x equals positive 10 and x equals negative 1. Just double check, make sure that those still work. If I plug in 10 plus 1 is 11, 3 times 11, that's cool. If I plug in 10, that's 100 minus 1, that's 99, cool. If I plug in negative 1 plus 1 is 0, 3 times 0 is 0. So this is automatically excluded. It's an extraneous solution. You don't want to include it. The only answer with 23 is 10. 24. Okay, give me a second to write this down. 24, x over x minus 3, x 3, 2x over x plus 3, 18, okay, so excuse my sloppy handwriting, but this is 24. This denominator is x minus 3. This is x plus 3, so they're different. And then this denominator has both of those different denominators, right? X plus 3 and x minus 3. So I think in this case, my least common denominator is going to be an x plus 3 and an x minus 3, because not only will it cancel this out, and it'll cancel this out, it'll cancel out this entire denominator. So this works for all 3 fractions. It doesn't matter that once we cancel this out, we've got a little extra up top, right? That x plus 3 will still be up top here. That's fine. Our goal is just to get rid of that denominator. So what I'm going to do is I'm going to multiply that entire equation by x plus 3 times x minus 3. So when I distribute this, x plus 3 times x minus 3 times the first fraction, I have an x minus 3 down below, and I'll have an x minus 3 up above. So those two will cancel out. All I'll have left is just the x and the x plus 3. Same thing with the second term. X plus 3 times x minus 3 times the second term. I already have an x plus 3 down below. Now I'll have one upstairs, so those two will cancel out. I'll still have an x minus 3 upstairs and that 2x. And then with our third fraction, when I distribute that, everything cancels from the bottom and from the top. All I'm left with is just an 18. So now I'm left with kind of still a nasty equation. I've got to clean it up, distribute, combine like terms, solve for x, all that kind of stuff. So here I will distribute my x. That'll give me x squared plus 3x. Here I'll distribute my 2x. So that gives me 2x squared minus 6x. It looks like I'll have a quadratic here. So what I'm going to do is go ahead and subtract 18 from both sides. So x squared plus 2x squared is 3x squared. 3x minus 6x is negative 3x. And then there's no constants on the left side, so it's just a minus 18. I've got a GCF. And then if I factor that quadratic, I'll have x minus 3 times x plus 2. So my two answers will be positive 3 and negative 2. Two possible answers. Let's make sure they both work. If I plug in positive 3, 3 minus 3 is 0. So right off the bat, that is extraneous. I can't include it. If I plug in negative 2, we're good to go. It doesn't make any of our denominators 0. So negative 2 is the only answer for 24. 25, a boat travels 8 miles upstream in the same amount of time it can travel 12 miles downstream. So let me get this on the screen for you. So this is a lot like the problem, I think it was example 5 that we looked at. In still water, the speed of the boat is 5 miles per hour. What is the speed of the current? So this problem's a little bit different. The only piece of information that you probably notice is missing from 25 versus example 5, I believe it was, is that he could, what was it? He could paddle an extra hour. He did paddle an extra hour upstream or something like that. That's not in this problem. So this is going to look a little bit different, but you're setting it up the same way. So it's a boat travels 8 miles an hour, 8 miles upstream in the same amount of time it can travel 12 miles per hour, 12 miles, I keep screwing that up, 12 miles downstream. So when they're telling you that, they're basically telling you that's your equation. It's going to be 8 equal 12, right? That's kind of what's going to be on both of your sides. 8 equals 12. So for 25, it'll be something like this, right? If you could travel one direction the same amount of time, that's what they're trying to get you to do, is to set them equal to each other. But it's not as simple as that, right? In still water, the speed of the boat is 5 miles per hour. What is the speed of the current? So that's really important. In still water, the speed of the boat is 5 miles per hour. So what you have to do is take into account, going upstream versus downstream. You're not sitting in still water. So for 8, this is talking about going upstream. You would have to subtract that current speed. And then for 12, let me just double check. This is going downstream. So you would want to have to add that rate. Okay. Upstream, you subtract, downstream, you add. And now we have our equation that we need to solve. This is just a fraction equal to a fraction. So again, I'm just going to do that diagonal multiplication shortcut. 12, 5 minus c. Distribute. 40 plus 8c equals 60 minus 12c. It's nice that there's no quadratics. So now I'm just solving for c. I think I'm going to go ahead and add 12c to both sides. and subtract 40 from both sides. So I have 20c equals 20, and divide both sides by 20. I get c equals 1. So what I want to do is first, I want to make sure that that's not an extraneous solution. If I plug in 1, it doesn't give me 0, so that's good. And then answer their final question. What is the speed of the current? So the current is going 1 mile per hour. All right, so if you're looking at these and you got any questions, you need some other explanations about things, feel free to let me know. I'm happy to do a Zoom call with you and help you out. Just shoot me an email.